Hello, everyone, and welcome to another podcast episode of Půdcast, a podcast from Carboneg about regenerative agriculture. My name is Lucy Pustrova, and I will be your host in today's episode. We are joined here today in Prague by Dr. David Purdy, here in Prague because he will be speaking at the Living Landscape Conference tomorrow, or the Živá krajina conference. And we are honored to not only have him as a speaker tomorrow, but also to be able to sit down with him today and have a conversation about his background in this field and learn a bit more about him. So thank you very much for being here today.
You're welcome. Thank you for inviting me.
Dr. David Purdy is a soil health specialist, a researcher, and an agronomist with over 30 years of experience. So thank you very much for coming today. Maybe first of all, I would love to hear a bit about your journey into this field, into soil health, and what kind of motivated you to go down this path.
Yeah, it's a long story. I'll try and make it really short, but it started when I was a teenager, really. I can remember I had a long walk home from school back to the farm where I lived, and I can remember just being fascinated by soils and plants and all the different things and growing food and farming, and that passion really started at such a young age, and it's just continued throughout my entire life and my career in a personal way and a professional way. And I'm really passionate about my soils and plants and agriculture. And I guess at the same time, as a youngster, which is strange as a young person, but I had a real passion for the environment. And so it was kind of natural that the kind of two things started to come together. And I've only ever really studied one thing and researched one thing and been involved in that industry for my life. And, I had the good fortune to have some really good education in that. And I've been really blessed with that. I've been surrounded by really good people who've encouraged me and helped me and supported me. And in turn, I've, now at an age where I in turn try and encourage and help other people around me. I've not only been involved in that in the UK, although a lot of that is obviously in the UK, but I've always had a real passion for kind of the underprivileged in the world as well, and particularly in a kind of agricultural context. And so I've had the privilege to travel to many different parts of Africa and some parts of Asia as well, and to try and share that kind of story, which when I started sharing the story, regenerative farming wasn't really talked about, but we knew at that time that looking after our soils, looking after the water within our soils, and generally being good to the environment around us was the right thing to do. And as the challenges become greater in some climates, particularly Africa, for example, we could see the benefits of looking after soil, looking after organic matter, looking after water and things like that were so important. In fact, they were crucial to the success of those production systems. So I've been, I've had the fortunate to study it, to research it, and to share it really with many different groups of people throughout my life. And I'm pleased to be in this country, your country, really, and share some of the stories and share some of the research. And I'm very research driven, so I don't just want to kind of take a few anecdotal things and roll them out to farmers. I want to take some of the kind of stuff, really research it, find out the real truth behind it and the data behind it, and then share that story. And really what we've discovered is that many of the principles, and we were using the principles long before, as I said earlier, that before regenerative farming became part of the agenda. What we've learned really is the principles work, but it's how you manage the principles within the context you're in. So that might be your climate, your soil type, your production systems. That's been the really kind of interesting part of our research, really. So that's a little bit about where I've come through and where I am today, really.
Excellent. I have so many questions to play off of what you just said, but maybe I'll start with kind of focusing on your research. So I understand you've been involved with Project Lamport for almost a decade. Is that kind of the majority of your research focus for the last few years?
I think we recognized, a group of us with some commercial partners as well, recognized that we were facing really significant challenges, and they're no different from the challenges we face here or we face in other parts of the world, but we face some really good, significant cropping challenges. We were seeing the pressures from weeds, pests, diseases. We didn't have new chemistry to deal with it. Much of the chemistry we had huge resistance problems. So we were facing really big cropping challenges. We recognized our soil health was, we estimate, and we've measured it, we've lost about 40% of our organic matter. That's probably true for many parts of the world. And with it, we had compaction, erosion, infiltration problems, all sorts of soil health related challenges. And then, we had the changing weather patterns and all the challenges that gave us as well. So, we had significant challenges, and we just had to stand back from those and say, how are we going to really tackle some of these big challenges? And so what we did was, Project Lamport, which is right in the middle of the UK, was born, and it was there really to tackle some of the cropping challenges initially, particularly how do we deal with some of the big weed pressures that we were getting that chemistry wasn't dealing with anymore. So we set about that kind of challenge initially. This is 13, 14 years ago now. And so what we involved spring cropping, we involved cover cropping, we involved trying to take out a lot of soil disturbance, a lot of tillage, not knowing that they were part of a regenerative debate, because we didn't have that word in our agenda back in those days. But we started to see, not only did we start to get our arms around how to deal with some of these pressures, particularly from weed pressures, but we started to see our soil starting improving. And that was kind of a bit of a spin-off. And then, as we saw our soils beginning, we began to see lots of function come back into our soil. So our soils were handling water much better, for example. We were beginning to see organic matters, and we measure it down to a meter deep. We do it very, very thoroughly. We're beginning to see organic matters starting to creep back up again. We're starting to see the structure of our soil, and we know structure of soil is so pivotal to many of the other processes and functions within our soil. That started to improve as well. And so, we began this journey, and quickly we were very excited about what we were seeing. Many challenges on the route. Not everything is just easy. And some people kind of say, adopt generative farming and everything comes right. Trust me, that's not been our experience. But what we've seen with when you start to change biology, it takes longer. It's a slower process, but it's much more sustainable. And the results do, if you manage it well, the results do eventually come. And so we started off just looking at some of the challenges, particularly cropping challenges, particularly weed and pest pressures. We saw soil health start to improve. So soil health became part of our agenda before soil health became part of the kind of more global agenda, if you like. And, the kind of rest is kind of history, really. And Project Lamport now in the UK has become a very well-known trial site. We have, system trials. We have a lot of replicated, randomized, highly scientific work going on, and the kind of combination of, sort of systems work and the replicated, more high scientific work come together to really support each other and deliver something that's, for us, it's been really, really exciting. And for every question we answer, another 10 questions come at us. So we never run out of ideas and research needs and things that come us, because the weather's changing, cropping changing, and many other things get thrown at us as well. But that's the kind of background to the project that we're going to be talking about tomorrow, I think, primarily, and the good things that we've learned from the UK. And I'm sure that will be helpful to many people in your country as well.
So you mentioned there was a lot of kind of challenges along the road. It wasn't necessarily a linear path. Can you maybe talk about some of the challenges you faced?
Yeah. So I think just going back to what I said, one of the biggest challenges is we were relying in the UK on things, either out of a can or out of a bag. That might be a chemical, it might be nutrition, or we're relying heavily on machinery and soil disturbance. We're relying heavily on those. And so when you rely on heavily of those, trying to come out of those, because many of them weren't working very well, does present some challenges. So if you come out of a system like that and go immediately to no tillage, so you go from one extreme to the other, we found that to be a challenge. But it was a good challenge, because what we learned is we could take out most of the soil disturbance. But what we learned is how to leave a little bit in some from time to time without damaging the soil. And I'll share more of that work tomorrow. But keep all the benefits from it, but without the kind of negatives from it. So that was one of the challenges. I think, obviously dealing with weather is that's continuously throwing challenges at us. So we see long periods of dry periods now in the UK, long periods of intense wet periods. And so we have to build resilience within our production systems to be able to cope with those two extremes. And I'll talk more about that tomorrow. But, you know, the way that when we have a living root, if you like, growing in our soil, that structures the soil in such a way that it creates a wide spectrum of pore spaces within our soil. So it's able to drain quicker, but it's able to also hold on to water quicker. And that's been one of the unique learnings of how biology really works in our soils and how that creates an environment to manage water and hydrology. But yeah, managing water has been a challenge. Actually, managing machinery has been a challenge, because machinery probably globally has been getting heavier and heavier, more and more disturbance. And we've kind of come back from that. And we said, we really want light machinery, minimum soil disturbance. And so that's been one of the challenges that we've overcome, and I could go on for a long time, but there are many challenges that we've learned and many challenges that keep coming us. We keep having to find solutions to. But one of the things I think, and just to conclude that, one of the things, the principal thing that we've learned, I think, is that we need energy in our system. And energy comes through photosynthesis. It's the primary and probably unique pathway for energy to come into our soils. And if you create a system where you're bringing more energy in than leaving the system, and it's a cycle, then you can start to see things changing. So that's the kind of unique thing, is managing our production systems that we bring more energy in than leaves the system, basically.
Are there like unique challenges kind of related to the climate or environmental context where you guys are doing the project that are relevant for farmers in the area?
I think so, because I think when you look at and we did, as I said earlier, we really didn't know the kind of different, these kind of principles of regenerative farming. We obviously, in a trial site, it's very difficult to involve livestock, so we haven't actually embraced livestock. We recognize the importance of it, but context is really important. So when the trial site was set up, we needed to have it in the kind of epicenter of where the weed pressure and weed burden was the worst, because we didn't want to go to a nice site where that pressure wasn't there. We wanted to learn. So the context for us is it had to be heavy soils, and it had to be a place where we get a particular weed called blackgrass in the UK. I think it is emerging in other countries, European countries, but it's a very, very invasive weed. It's a grass weed with very little chemistry now that controls it. And so we have to control it using cultural methods, really. So we wanted to be where the worst of that was, and we wanted to be in heavy soil types. So we're in silty clay loams, bordering on clay loams. And, when you get a big high fraction of clay, high fraction of silt, that's a really challenging soil to be involved in. Because what we didn't want is farmers to come in and say, well, that's all great, you're doing a fantastic job, but you're in a nice part of the country with nice soil types and things like that. We wanted to be able to prove that we could make cover crops, no tillage, all these things work in a very challenging kind of soil type, very challenging thing. So climate is climate, that will come at us whatever we do. But primarily the two things that we wanted to be involved with was where high weed pressure and challenging soil types come together, if you like.
And do you find that the principles you've applied, would you expect them to work in pretty much every context, or do you think there's kind of certain areas that they maybe don't make sense? Well,
that's a really good question. I mean, the first thing that people kind of said to us was, it'll never work in those soil types. You'll never ever, moving from, the challenge we have is that we can only grow sort of one winter crop. So we grow a winter wheat, for example. If we try and grow a second winter wheat after that, the weed pressure becomes so great that it becomes kind of uneconomic. So we can grow 1 year of what we call first wheats in the UK, and then we have to go into some other sort of cropping. So for us, that was going into a spring crop, but the spring crop obviously gives us the option to go to cover cropping. And everyone said that won't work. On those soil types in that part of the country, that won't work. And what we prove without any shadow, it's just how well it does work. But, and the big but is, what we've learned is all these principles are great, but it's the management of those principles that is different for different contexts, different soil types, and different situations. So, and we very often, for us, managing our cover crops, we have to plant them early. That's before the end of August. We have to terminate them. I'll go into that in more detail tomorrow. We have to terminate them early. For us, that's January. And if we plant early and terminate early, cover crops are very, very successful for us. But if we were to plant late into September and terminate in March, cover crops can be very, very challenging and often produce a negative result. And therefore people think, well, cover crops don't work, do they? And so these things work if you manage them properly and you understand. That's where science really helps us understand how to manage them properly. If you manage them badly, they can also, they can what we call kick you or be very challenging. And so for us, the context will just be a different way of management. If you go into lighter soil types, you might have to manage them differently. If you go into heavy soil types, you have to manage them differently. And you have to learn how to manage them. I think the principles work wherever you are in the world. The bit's different is how you manage them.
How would you define success with cover crops?
So if you adopt cover crops purely because you want them to increase yield, sometimes they will do that. Sometimes they won't. If that's your only criteria for success of cover crops, then probably they might not be for you. Because what we found is the real success of cover crops comes in the functional changes to our soils, and they're immense. So, improving hydrology, improving soil structure, providing nutrition, that's a really big area to cover. But all these things are big functional changes to our soils, which in a sense, nothing else can do. So if you're interested in the broadest kind of benefits from cover crops, then they're probably something for you. If you're just focusing on yield, then they aren't always going to produce yield. So success for us is how functionally our soils behave better, how they handle water better, how they provide nutrition, how they structure themselves better, how they're more resilient to handling machinery on them, and things like that. That's where cover crops really bring for us the biggest benefit, not just, do they increase yield? Because they don't always do that.
And how do you define soil health? Because you've mentioned, some of the factors such as hydrology, structure. Is that does that go into the big picture?
I think for us, you can measure, there's a difference between success or soil health. You can measure soil health, that's a kind of separate subject. For us, it's really simple. It's how the soils function. And, if you can take soils from big, ugly, poorly structured, low organic matter soils to we're dealing with challenging silty clay loam soils, and clay loam soils are challenging soils. But if you can take them from a poorly structured, low organic matter to well-structured, improving organic matter, that's a journey of soil health. It's so for us, it's the way the soil functions. And we've talked about it already, but particularly around how the soils manage water, how they structure themselves, how you can see biology. Worm counts, for example, are a classic example. So we don't have to get too kind of technical about it, but there are some simple ways of measuring soil health. But for us, primarily, it's how those soils function in that particular context, which for us is what soil health is all about.
And was there a moment where you kind of realized, or it clicked, how important soil health is kind of to the entire ecosystem of agriculture? I'm
not sure there was one moment, but I think as we were forced to go to a spring cropping system for a couple of years, to go back into our first weeds to deal with grass weed problems. Of course, we involved cover crops, and we didn't expect to see it because we're going back quite a lot of years now, but we began to see going from these kind of big, blocky, angularly, poorly structured soils to this soil that just falls apart in your hands. And see that come alive in a real world situation, a real field situation, not on a YouTube clip, was for us a little bit of a eureka moment. And then with that, we suddenly, started measuring worms, and we were getting, in a spadeful, a shovelful of soil that's about 20 cubic centimeters. We began to go from about 4 worms if we were lucky. Now we can see anything from 20, 22, even 25, sometimes 30 worms per spadeful. So I think, seeing biology respond, seeing soil structure respond, and then after a big heavy rainfall event, we can walk across our kind of trials, if you like, and you can see where we've kind of reduced the amount of soil disturbance, where we've used that concept of living roots as much as we possibly can. We can see that, you can walk across it even on a very wet day and your welly boots are clean, or your boots are clean. And then you go into a heavy tillage plot that doesn't have cover crops in it, and your welly boots are full of mud. So there's lots of visual things. Of course, we've measured microbial stuff, and that's all exciting as well. But that's kind of those kind of moments really kind of stand out in your mind.
And you mentioned that, in the transition kind of to improving soil health and to really seeing those tangible changes, it's not an overnight process. It sometimes takes a few seasons, a few years perhaps. And in your experience, kind of with farmers trying this transition and experimenting, kind of what are the early challenges or hurdles that they have to overcome, and sometimes maybe cause them to kind of second guess and reverse?
Really good question. And I think just taking a step back from that is that many of the things that we're trying to achieve are biological changes within our system. And biology is incredibly more powerful than, say, soil disturbance. But the big but is it takes time. And it doesn't just come out overnight. So one season of cover crops don't change your world. Building it into a sort of 3, 4, 5 year rotation suddenly makes a huge difference. So you have to be patient. So the kind of key ways we transition people into that kind of way of thinking is and that's a lot of what we're researching is, and I've mentioned it before, is how we manage that living root within the context. And so management is super critical. And the other thing is, and we don't always know this until after the event in a sense, but if you suddenly, especially on some of these challenging soil types, suddenly remove all your soil disturbance, remove all your tillage overnight, then if you've got poor organic matter, poorly structured soil, that can cause some challenges. But what we've learned is that we can very quickly remove all deep tillage. And what we mean by deep now is anything deeper than 100 millimeters or 10 centimeters. Mm-hmm. So we concentrate all our disturbance now in the top 100 millimeters, 10 centimeters, and our soils are structuring themselves beautifully at depth. So we don't need to worry too much about depth now. We just focus a very shallow amount of soil. We call it stretching the soil. So, and that way we keep the strength in our soils, but we get all the plant response from that we need. And so it's about two things: about careful management of the living root, and it's about understanding when and how to remove disturbance out of your system, and then if you need to keep disturbance, in what that really looks like. And I'll share more about both of those obviously tomorrow, but they're the key kind of things as you transition that you probably need to focus on.
So would you say that's kind of the main first step, is minimizing tillage?
Yeah. I mean, you could do it overnight, obviously, because it's just a decision. But I think because no one wants to see their yields fall off. And even in research, we don't want to see our yields fall off. We've not really experienced that. But the way we transition that is to make sure, well, two things really: make sure we haven't got any problems with our structure at depth, mm-hmm. And then removing all disturbance until you focus just on the sort of seeding depth, really. So you get good seed to soil contact, good tilth and things like that. And then making sure you don't actually put any damage back into the soil. So for us, that's about, probably lightening up our machinery. So most of our axle weights now, we try and keep below 6 tons, and we try and keep our tire pressures below 10 PSI. And combination of those two, there's quite a lot of research behind that, but the combination of those two really prevents further damage. So prevention is better than cure. And those kind of things combined really help us transition quite quickly, to be honest with you.
Is there one area kind of in the transition that you find farmers have a harder time accepting?
Yeah, removing tillage. Yeah, people just love it. Mm-hmm. And it costs them a fortune. It's damaging the soil in the process. And I'm not saying you can just go no-till overnight, because we're definitely not saying that. Our research suggests that we can't just do that overnight. But people really struggle. They even though it's costing them a lot of money, even though potentially it's obviously oxidizing a lot of carbon, potentially causing damage to soil, we still love tillage. So that's the hardest bit, really.
Yeah, maybe a funny personal note. I have a young son, and I've been buying him some books, and I like the topic of farming, obviously. And so, so a lot of the books are kind of in that general topic. And there's always some mention of tillage, even for like young children's books. It's so ingrained in our kind of view of agriculture.
I think it's then important, doesn't it? It's as you say, it's so ingrained. Then it's important to provide research, provide understanding of how we transition perhaps out of that. And I think, you know, that's one big piece of work that we've done, is trying to understand in a challenging soil type. You know, if you've got lovely, loamy, lighter soils, it's probably much easier to transition out of it. But if you've got heavy soils with some challenging soil chemistry as well, then that's much more difficult thing to do.
In regarding soil research, are there any kind of like very like pressing questions that you hope to answer in the next few years? Like what is kind of top of mind of like, I need to focus on that?
Yeah, so I think we've looked at soils, we've measured just about every way you can measure soil, whether it be a chemistry, whether it be biology, whether it be looking at physics. So we've looked at it in those three contexts, and we've measured everything we can grab, including use things like AI and all sorts of things. I guess the one piece of linkage that we're just going to research this year is, first of all, understanding is as we get into more no-till and as we get more living root in there, we expect to see the colonization of our roots with a vascular mycorrhizal to go up. So we've done some limited amount of work on that already. It's quite painstaking work. You have to stain the roots, and we can see that we are getting higher levels of colonization. But what we want to link is there's quite a lot of research out there that suggests as you get higher colonization, so 30, 40, even 50% colonization, then the plants give off sort of volatile compounds that then repel things like aphids, for example. And aphids are big carriers of different diseases, really, but also they repel aphids, but they would attract, say, a parasitic wasp, which would eat the aphid. So
interesting.
Yeah, it is. So look, there's some good research out there looking at that stuff, and we want to, in our context, just always context specific, we want to try and do that. So this year we're really focusing on some of that, but also just generally, you know, we want to make it an important thing for farmers and growers is this has got to pay. It's got to be profitable. It's got to be economical. And for us in the UK, the most economical point in a production system is first wheats. Is winter wheat. We know we can't grow 2 years of winter wheat because we get huge grass weed pressures, but we want to get back into our first wheats as early planting, because we're delaying planting later and later to let more weeds grow so we can kill them off before we plant. But we want to get back early, an early drilling date in September or even August. And, you know, we want to maximize in a no-till environment with very little, sniff of chemistry. So we want to make that, that point in our production system very economically profitable for the farmers. Because if it isn't profitable, farmers aren't going to do it. But what we've also learned is when we go to spring cropping, we introduce, say, a spring crop like spring wheat or spring barley or spring oats. The cover crop allows us to be very, very successful as well. But we're bringing a lot of diversity into the system as well, and lots of kind of other good benefits as well. So, so I think for us, 2 bits of research we're going to do: a bit of highly scientific stuff, where does biology really help us kind of deal with some of the pest problems, and then just kind of making sure this stuff is really economic and stacks up for farmer. Because we, as scientists and sort of health enthusiasts, we get ever so enthusiastic about this stuff, but we sometimes forget that it's got to work economically for our farmers and growers.
Have you found any specific cover crops or mixes of cover crops that are like particularly successful? Yeah,
so that's always a question. Everybody asks, well, what cover crops do you use? There's a few key things to bear in mind in that. First of all, in the context, we keep coming back to the context, but you got to grow what will grow. So first thing is we know what actually will grow. There's no point in planting stuff that doesn't grow in that context. So you've got to grow what you can grow. That's the first thing. Secondly is it's all about planting date for us. So if we had to be planting a little bit later in the beginning of September, a lot of things just don't grow in September. So clovers, for example, really, really struggle. So if you're having to plant a little bit later, then the species that you no point in planting because and I'll show you tomorrow, they won't grow. So and then the third thing is, so it's what will grow when you plant, and the third thing is what do you want them to achieve. If you want them to just absorb a lot of nutrients, and you know, our utility companies, our water companies in the UK love that, then you might grow a brassica. But the danger, we don't get too involved in brassicas, is you bring in the slug pressure into the system. So you've got to be mindful of those things. If you're dealing with very tight compacted soils, there's certain species like some of the radishes, but also some of the black oats as well, that will start to deal with high bulk density compacted soils. So depending on what you want to achieve, the species will determine it. Depending on when you plant them, it will determine the species. Depending on what actually grows in your environment, species. For us in the UK, what's been really successful is things like Phacelia, black oats, buckwheat, clovers, as long as you plant them earlier, some of the vetches. Those are the kind of main things that we kind of, Phacelia, they're the main things that work for us really, really well. So.
And how do the kind of key challenges compare with the farmers that you've worked with in the UK, with, for example, the farmers that you've spoken to in Africa, in like such an entirely different context? Yeah,
you know, the word, in some senses, when the biggest, probably the two biggest challenges now, or three biggest challenges in Africa, for example, is there's a lot of soil disturbance. So they just love deep ploughing. They burn off, you know, Africa was on fire at the beginning of the raising season. They just burn off all their organic matter just to make growing things a little bit easier. So they're oxidizing a lot of organic matter, and they're not putting any organic matter back in because they just burn it all off. So the soils are, generally speaking, it is just sand, silt, and clay. It's just dirt rather than soil. So the biggest challenge there is trying to remove soil disturbance and trying to stop people burning. They're massively cultural things. So, and then rotation, you know, is trying to build in other plant species within the rotation, particularly say a legume like a soybean, for example, or groundnut, which is also linked. So it's trying to build rotations, trying to stop a lot of soil disturbance and trying to keep the organic matter where it really needs. And so the education in Africa is really simple around those three things. But because the climate is so harsh, and because if you can stop doing those things or build those things, the differences you can make can be tenfold almost in 1 year. You know, they measure everything in bags per acre, which are generally 50 kilogram bags, but you can go from a couple of bags per acre to 10 bags an acre overnight. It's all about water management and soil management and using kind of, you know, mulches and things like that. So in the more developed, I'm using that word really carefully, but in more developed parts of the world, like we are in, okay, the differences are much smaller because we're doing many of those good practices anyway. So I think those are the kind of big kind of differences really that we've seen really in those two different contexts really. So.
Yeah, I mean, as from what I understand, like water management is such a critical component as well, due to soil sequestration or due to carbon sequestration. I think I just saw a research article recently that said that there's like kind of a specific range of, I guess, soil humidity that's like optimal for carbon sequestration. So I imagine if you're working with extremely dry soil for most of the year, that's like also quite limiting.
Yeah, look, if you want to bury some carbon, the two things that are really critical is temperature and moisture in terms of climatic, but also structure. The biggest thing, if you've got good soil structure with air and all the biology is working well into it, then you stand a much higher chance of sequestering carbon. If you've got poor structured, dry soils that are hot, it's much different.
So yeah, the public perception of agriculture and climate change is definitely evolving. And what role do you think kind of agriculture or soil health in particular can play in the kind of like larger climate narrative?
Yeah, that's a super question. I think, you know, many people put a huge amount of spin on this, saying we can be the solution to climate change. We can bury all this carbon in our soils, and you know, and the rest of it. And that is a potential. You know, that is out there as a potential. I think if we, you know, just put my science hat on, if we overly sell that as a principle, put too much spin on it, I think we'll just come a little bit unstuck. So, you know, the carbon coming back in the soil will bring many functional changes to our soils, will do much good to our soils and our production systems. So there's a lot to be gained. Over time, I think we can pull carbon down, you know, we can pull these CO2 equivalents down into our soils. We've certainly proved that. If we're expecting large amounts of carbon to be pulled down super quick and suddenly be the kind of answer to climate change, it is going to take time. It may happen in time, but it's going to take our time. So I think I'm being super cautious about that, but I think our principal focus should be on the way that carbon can deliver into our production systems, all the functional changes we've already talked about. I think as time unfolds, and we'll only learn that as time unfolds, then it can play a role. How big that role is yet to be defined, I think, really, in that kind of ultimate goal of addressing climate change. In theory, it's definitely out there. I think it's just going to take us a little bit longer than perhaps some people first imagined to be able to do that. But let's be honest, the only route we've got, just to kind of put a bit of a pun on it, but the only route we've got to bring this carbon back out of our atmosphere, I think we're at sort of 400 and odd, 20 parts per million at the moment, to bring that back down, the only route we've got is plants, trees. That's the primarily, photosynthesis is the primary method we've got to do that. And so the more photosynthesis we can get into our agricultural production systems, then the potential is almost endless. But I think we just need to be sensible about the claims we make and the potential that is there, certainly in the short term anyway.
Excellent. What is your kind of biggest hope for the future of agriculture? Either in the UK context or globally?
Yeah, I think it would be good that governments around the world, my world is very much Europe and UK centric, and to some extent Africa and some parts of Asia, would value what we're doing in agriculture more. I think, in some countries that is valued a little bit more. I think, we have such a big part to play in looking after the environment and producing healthy food. And, we use that word cautiously in, improving soils, doing all sorts of, managing water and reducing flood risk and all sorts of things we can play a really important and big role in. These are called ecosystem services. But sometimes you think the government don't really value the role of agriculture, the role of farmers. And I think so one of my wish, if you like, would be that governments around the world would value what farmers and people with involved in the industry, particularly when you're trying to do the right thing, particularly when you're trying to move away from the kind of industrialization of it into a more sustainable, kind of more environmentally friendly way of producing food. So I think for me, that would be probably pretty high up the list, really. Things I'd like to see.
So if you could suggest one agricultural policy to take place that would kind of exemplify valuing farmers more, what would that be?
I think just it goes back to what we've kind of been talking about. And, I guess it is the kind of regenerative agenda to some extent. But we know now through lots of people's research and through our own research, the value in bringing, I think for me, it comes back to that simple thing is bringing energy into our system. So I think, if there's one thing that we could reward, it's that mechanism of using plants within our production system. So it could be a cover crop, it could be a catch crop, it could be a companion crop, but using those kind of principles to bring energy into our system. Because that has lots of wins. It has wins for the environment, has wins for the carbon agenda, it has wins for just bringing good functional benefits to our production system. So for me, it comes back to that one thing of bringing energy back into our system through photosynthesis.
Thank you so much, David, for joining me here today and for this conversation. And thank you to our listeners, and see you next episode.
Thank you very much.